Hello guys, welcome back to my channel Maison African Motifs, still on engineering science and for working on stress, strain and the Young's modulus of elasticity. We have a question from the July 2018 paper that we are going to focus on. Here we are given the question that we have got the ratio of external diameter to the internal diameter of a steel pipe. So take note, this is a pipe like this. Okay, let me just like show you a presentation of what is happening. Maybe this is our bigger diameter, where we are going to have our bigger diameter here. Then there is here an internal, okay, diameter that is going to affect, guys. Okay, I don't know how am I going to put this one, but you understand like what is going to happen here. All right, so this is like this, guys. So in between here we have got the internal diameter, which is D. All right, so we are given this diameter, the ratio, which is D as to D, like this, the ratio of the bigger diameter to the smaller one, external to internal, which is 3:1. So it's 3:1. All right, then let's just take our information, then I'll explain the other things later on, because there's so much that we need to explain there. We are given a compressive force also of 620. So let's just list our information. Our force of 620 kilopascal, and remember kilo means to the exponent of 3. We shall see that one later on. And the length decreases by, which means you are given the change in length, which is x, which is an extension. All right, so we've got x, which is an extension of 0.771 millimeters. So definitely we have to convert to meters, divide by 1000, which is going to give us 7.71 actually, okay, times 10 to the exponent of -4 in millimeters. In meters, guys, we have converted to meters now. All right, then we are given the Young's modulus of elasticity of the material, which is 209 gigapascal. All right, so we are given E, which is 209 gigapascal. All right, then the initial length of the pipe, this is the length of the pipe, which is L, which is 3 meters. All right, we have our information. Then what is the question now? The question is to calculate the external and internal diameter of the pipe, and that's 6 marks, which means we've got a lot of things to handle there. Okay, we have to find D and we have to find D, the internal, okay, and the external. All right, so where can we have these two being found? Where can we have this? Because we need to know where actually we have got these values. All right, the only part that can give us the diameter is where we have area. That is the only thing that we can have, which means we must have area. Why must we have area? Because we know that area actually is supposed to be equivalent to pi d squared over 4. But now take note, the area is going to be affected because you are going to remain, because this is like a hole. This one is like it's actually a hole that is there. So you want to have, or you are going to remain with this particular portion. This particular portion is the one that you are going to remain with. So if I am going to remain with this particular portion for my area, therefore, because look, there's a hole here, so this is the area that you want of this hole, so you are going to subtract the diameters. All right, remember we said the area is equivalent to pi d squared over 4, but because of the diameters, therefore we are going to subtract. So this one is no longer going to be written like this. It is going to be written as pi d squared minus d squared, like this. You subtract the diameters over 4. That is now our area. So that means we can play around, because what we want is to find what? Is to find an expression for the diameter in terms of area, because area is easy. We can find this area from these values here. We can find this area from all these values. They can give us the area. So let us make an expression either for this D or for this small letter d. We can just make any to be the subject. All right. So what can we make to be the subject here? We are given that ds to d is 3:1. This, what does this mean? It means that d is equal to 3d, like this small letter d, because it's like this. Ratio is like this, guys. Okay, let me put it this way so that you can understand me. When you write ds to d like this, it means d over d is equal to 3/1. That is what that ratio mean. So it means that you can actually cross multiply 1 times d, which is d, 3 times this d, which is 3d, like this. So you have got d, which is represented by 3d. So in place of d, you can substitute with 3d, because you need to calculate one so that you can find another. All right. So from this equation, we said d, this d is for the external diameter. Take note, it is equal to 3d. So in place of this external diameter, we can represent this as area is equal to pi into d squared. So our d, we said it's equivalent to 3d, like that, but this is squared. So if we square this, it is going to give us 9d squared. So in place of d squared, we are going to have 9d. So we have written now in terms of d squared. All right, so these are now like terms, because now it's in terms of the small letter d, minus d squared. Yet there's nothing that is going to change. It's going to remain like that. All right, everything over 4. So a is equal to pi. This is just same as 9 minus 1, which is going to give us 8. So we're going to have 8 d squared over 4. So definitely divide by what? By 4 is going to be 2. Okay, if we are together, I hope you are together, guys. So what we need, why am I doing this? Someone is asking, but why am I doing this? We want an expression for d in terms of a, because we said a is easy. We can calculate a direct, but we need to know after that a, how are we going to have our d? All right, so this is going to give us 2. So a is equal to 2 pi d squared. So definitely divide by 2 pi by 2 pi. It's going to cancel. So that means small letter d squared is going to be equal to a over 2 pi. So square root both sides. So your d is going to be the square root of area over 2 pi. So this is your expression. This is your expression that you're going to use to calculate this internal diameter when you have the area. Where are we going to have the area? Someone is asking the question. This. All right, the area, we can determine this in an easier way. Remember, guys, I showed you this formula in another video where I told you that using this formula you can obtain a lot of things: the force, the length, the area, the extension, as long you can apply this formula. So let's apply this formula and calculate our area. Okay, so E, which is our Young's modulus, is equivalent to FL over AX. Okay, so let us make area to be the subject of the formula. Just cross multiply here. All right, so it's going to be EAX, which is equal to 1 times FL, which is FL. Remember, we want to make area to be the subject. So what are we going to do? Divide by EX by EX. So this is going to cancel. So your area is equivalent to FL over EX. So now we can substitute. Why? Because all these values, we have them here. Remember, guys, we have got these values here. So let's substitute. All right. F, we have got 620 kilonewton here. So it's going to be 620 times 10 to the exponent of 3 times the length here, which is 3 meters, over EX, which is your Young's modulus, 209 giga, means to the exponent of what? Of 9. So it's 209 times 10 to the exponent of 9 times the extension. Remember, your extension now in meters is now 7,71 times 10 to the exponent of -4 in meters. So okay, it's in meters, just leave it like that. We know that it's in meters now. Okay, so that is an expression for your area. So using this, definitely you're going to obtain your area, which is going to be something like 0,0115428, something like so. You just have to write as many digits. So this is your area, where we know that our area is measured in what? In square meters. Using this area now, remember our main aim is to calculate what? The diameters, and we have an expression that we derived together here. Remember, we derived here to make D to be the subject, and we say D, which is the internal diameter, is equal to square root of A over 2 pi. All right, from our derivatives that we from our derivations that we did, this is our D now. So let us put these values, because that is what we want to calculate. Now we have the area, so it's going to be easier for us. So as you can see, some of these questions are play around questions. You have to play around the given information. All right, so our area, guys, this is our area here. Let us substitute our area, which is 0,011542, something like that. You just have to put as many digits as possible. This, guys, if you round off here, it's not going to give us something that is exact, okay, over 2 pi. So make sure everything is under the square root, okay. This is going to give you a diameter in this case, which is let's see, guys, we are going to have something like 0,04286, something like that. So if you round off properly, just to 3 decimal places, it's going to be 0,043. This is 3. This will be in meters. So it depends. You want to convert to millimeters, or you just convert if you want. But this is your D, this is your internal diameter. This one, which is an internal diameter. Remember that. And we said our external diameter is D. So this one, where are we going to have it? There is a relationship that we had before. So we are just going back to that relationship. Remember, we said D is equal to 3D. From that ratio of D, S to D is 3, S to 1, and we said D is equal to 3D. So using that relationship that D is equal to 3D, it's going to be easier for us now to find this external diameter. So this is our external diameter now. All right, so which is going to be 3 times the internal diameter, which is 0,043 meters. So that is going to give us 0,129 in meters. So that is your external diameter, your internal diameter. So as you can see, guys, it was actually a play around question where you have to play with the formulas, the information that you have, and sometimes that's how these questions, they might be given, like, and you have to be very, very careful about that typical question. Anyways, let's see another part of the question that we had, which is on 7.2, where we are given same information, just that we have to apply like the way they have given us now. We are given a STY, which is 4 meters in length. Okay, so that's a length that you are given of 4 meters and 8,000 square millimeters cross-sectional area. So this is an area of 8,000 square millimeters. Sorry. So remember that the relationship that in a square meter we have got 1 million square millimeters. So if we have got 1 million square millimeters, definitely we have to divide by 1 million so that it can be in square meters. All right, so we have to divide so that it can be in square meters. So if you do that, guys, if you divide, you are going to obtain 8 times 10 to the exponent of -3, which is now in square meters. So this is your area. All right, so I think these guys, from your mathematics, you can understand much better. And we are given a load which is applied, which is 38 kilonewton. So we're given a force of 38 kilonewton here. All right, what else? And the wire exerts, take note here, and it extends, which means we are given an extension, a change in length by 0.15 millimeters. So that's a change in length of 0.51 millimeters. So this is millimeters divided by 1000 to be in meters. So if you divide by 1000, guys, you're going to obtain 5.1 times 10 to the exponent of -4, which is in meters. All right, so that is your information that you have for now. With this information, then how can we determine, or how can we calculate 7.21, which is the stress? How can we have our stress, guys? Which formula are we going to use to find the stress? Remember, stress, that is alpha. It's written as alpha, like this, alpha, which is the force over the area. Okay, where's my formula sheet? Some of these things you have them, force over area, everything is there, you're given. So you have to know now the information that you have and how to put in your information. So the force, do you have the force? Yes, I have, which is 38 kilo. That is kilo to the exponent of 3 over the area. Do you have the area? Yes, we have got the area, which is 8 times 10 to the exponent of -3. So this is going to give us our stress. All right, so this is going to give us 474,750,000, like this, in pascals. All right, then we can actually convert to megapascals. How do you convert? Remember, mega is to the exponent of 6. So to convert to megapascal, you divide by to the exponent of 6. So you divide by 10 to the exponent of 6, and this is going to give us 4.75, which is now in megapascals. All right, so we divide by 10 to the exponent of 6, which is the opposite of mega. So this is your stress. All right, so our stress is there, and we move on to the other part, which is to calculate the strain. Okay, so strain, which is given by the formula, the change in length over the length, original length. So that's our strain. That is the change in length over the original length. So do we have the original length, the change in length? Yes, we've got 5.1 times 10 to the exponent of -4 over the original length, which is 4 meters. All right, so this can give us the stress, the strain in this case, which is our strain, is going to be 1.75, 1.275, yeah, that's 275 times 10 to the exponent of -4. And here we do not have any units because it was meters over meters, and this cancelled, so it's just going to be a constant. All right, then we move on to another part, which is 7.23, where we are now given 7.23 to calculate the Young's modulus of elasticity of the steel, where we are given that as the stress over the strain from this formula, right? So our E is going to be the stress over the strain, and our stress, we have got it here, 4.75 times 10 to the exponent of 6. Remember, megapascal is to the exponent of 6 over, so this is in pascals, over the strain, which is 1.275 times 10 to the exponent of -4. This has got no units, so therefore our E is going to be in pascals. Okay, so if we do so, if we divide, guys, let's see what you're going to have. It's going to be this digit, guys, 3 something like that, 3.7254 times 10 to the exponent of what? Of 10, which is in pascals. So for you to convert to gigapascals, remember, if you want to convert to giga, it depends with where you want to convert, mega, giga, whatever, you divide by the opposite. Remember, gigapascal is to the exponent of 9. So we have to divide by 10 to the exponent of what? By 10 to the exponent of 9, so that it can give us a gigapascal. So that's how you simply do it, guys. So I don't know what you're going to obtain if you divide properly. Okay, so as for me, I'm obtaining something like 37.25. Remember, this was 4.9 549, so it's going to be 55 if you round off. I don't know, just round off properly, guys, or you can just put it as 3 like that. It's fine, but this is going to be in gigapascal. Remember, we converted so that it can be in gigapascal. So you divide by the opposite. Giga is to the exponent of what? Of 9, so you divide by 10 to the exponent of 9. If it is mega like this one we had here, where we've got this in pascals, and we wanted to convert to megapascal, where we know that mega is to the exponent of 6, you divide this number by 10 to the exponent of 6. The value that you obtain, it will be in megapascal. So you're going to obtain 4,75. That value that you obtain is in mega, so you're going to write M for that. It's going to give you a decimal, but that is in mega. The same thing with this one is going to give you 37, whatever that you're going to have. That value is in gigapascal because you divide it by what? 10 to the exponent of 9. So that's how some of these questions, guys, that's how they actually present them. So working with formulas, with your formula sheet, and linking the formulas with the information, like the first question that we had on 7.1, you had to link the information with the one that you're given on your formula sheet, which is going to help you. So that's it, guys, from us on African motives, working on engineering science, and for that is working on question papers and revisions. So let us just, guys, encourage others, and also to share our videos to our colleagues and friends, so that they also can benefit from this information. And don't forget to be part of the family by subscribing to this channel. So that's it, guys, till we meet again.